Hey there everyone! How are you? I hope you're doing fine. By the way, I am Henry Cesar Salvador, 17 years old, and I am a STEM student who is hoping to be a successful civil engineer someday.
So yes, hello there guys, I'm Sophia Julian. I'm also 17 years old and wants to be a successful engineer too. So we are the grade 11 students of Rizal National Science High School. So we're doing this video because we want to help other people who are struggling, especially with math, to at least somehow have extra help in doing those kinds of exercises or just confusion within lessons.
By the end of the video, you are expected to get the derivative of the function and to get the equation of the slope of the tangent line, and we are going to relate the two, the derivative of the function to the slope of the tangent line. Let's start now.
The slope of a tangent line. The slope of a tangent line is equal to the limit of f of x minus f of x sub 0 all over x minus x sub 0 as x approaches x sub 0. So this is the slope formula. On the other hand, y minus y sub 0 equals the slope of the tangent line times the quantity of x minus x sub 0 is the equation of the slope.
So what we have here guys is example number 1, which is f of x is equal to x squared plus 1 at 1, 2. So now I'm just showing you how to get the slope of a tangent line with this formula, which is the limit of f of x minus f of x sub 0 all over x minus x sub 0 as x approaches x sub 0. At this point, I'm just showing you on which of the following one is which. So f of x sub 0 is the y coordinate, f of x is the equation, x sub 0 are the x coordinate, and x will just remain as x. So we can now substitute the limit of f of x, which is the equation x squared plus 1, as you can see, minus f of x sub 0, which is the y coordinate, so 2, all over x minus x sub 0, the x coordinate, x minus 1, as x approaches 1. With that, we can now simplify. So x squared plus 1 minus 2 will turn to x squared minus 1 all over x minus 1. At that point, we would not substitute the approaching value immediately, but we have to manipulate the numerator first to x plus 1 times x minus 1. Now we can cancel x minus 1, and it will leave us with limit of x plus 1 as x approaches 1, and substitute the value of the approaching value, which is 1, so 1 plus 1, the limit is 2.
Let's now get the equation of the slope. Y minus y sub 0 equals slope of the tangent line multiplied by the quantity of x minus x sub 0. Substitute. Y sub 0 is equal to 2, so it becomes y minus 2 equals 2, or the slope of the tangent line we got from the previous solution, multiplied by the quantity x minus x sub 0, which is equal to 1, then multiply, so it becomes y minus 2 equals 2x minus 2, transpose negative 2. Y is equal to 2x minus 2 plus 2. Simplify. We now get the equation of the slope, which is y equals 2x.
Let's move on to derivatives. So, to get a derivative of a certain equation, you will need this formula. So, f prime of x is equal to the limit of f of x plus change of x minus f of x all over change of x as change of x approaches 0. Now let's recall. As you remember, in the past lesson from the slope of a tangent line, they also represent somehow it's the same kind of equation, formula, but this time derivatives is the average rate of change of secant lines, while the other one is for tangent lines.
Limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. We are going to square x plus delta x since the function is in square. So it becomes limit of x plus delta x square plus 1 minus the function which is x squared plus 1 all over delta x as delta x approaches 0. Expand. Limit of x squared plus 2x delta x plus delta x squared plus 1 minus x squared minus 1 all over delta x as delta x approaches 0. We can now cancel same variable with different signs. So, we have now limit of 2x delta x plus delta x squared all over delta x as delta x approaches 0. We can factor the numerator since they have the same delta x. So it becomes limit of delta x times the quantity of 2x plus delta x all over delta x as delta x approaches 0. Cancel delta x. So we now have limit of 2x plus delta x as delta x approaches 0. Since that delta x approaches 0, what we have is 2x plus 0, simply 2x. So with our lesson, a tangent line is a straight line that touches a function at only one point. This tangent line represents the instantaneous rate of change of the function at that one point.
Get the derivatives of the following functions. 1. 4x minus 1. 2. 2x cubed plus x squared.
So now, you'll be having 5 problems. Get the slope and the equation of the slope from the following functions. Number 1. f of x is equal to dx plus 3 at 1, 5. Number 2. f of x is equal to 3x squared plus 2x at negative 1, negative 1. Number 3. f of x is equal to x squared at 1, 1.
Get the derivatives of the following functions. 1. 4x minus 1. 2. 2x cubed plus x squared.
That's it, guys. That will be the end of our video. Once again, I am Henry Cesar Salvador. Till next time, bye!
And that is it. Thank you for watching.